Okay, we know we have spoken a little bit about acids and bases and all earlier as well. I'm sure you know acids are donors of H plus, something that produces H plus in water. Bases as something that produces OH minus in water. We have always heard of this, that acids and bases react with salt. Acids and bases react with each other to give us salt and water, right? But yeah, do you also know that salts can also be acidic or basic based on what is the source of that salt? I mean, what acid and what base was used to make that salt. So if you have something which is a salt like NaCl, which is made out of what? A strong base NaOH plus a strong acid HCl, then the salt that we have NaCl is something which is neither acidic nor basic, right? So on the other hand, if I have something like, let's say for example, sodium carbonate is made out of NaOH, which is a strong base, and your weak acid carbonic acid H2CO3. Now when you have a salt like this, whatever is strong, although the details involved here about basic or acidic character and all and pH calculation and all is much more detailed, we will be going through that in our classes. But the basic idea, what trick you can use to remember is, if something is made out of acid and a base and we want to determine the nature of that salt, see which is strong. That will be the overall nature of the salt, right? So here when I'm looking at something like sodium carbonate, I have sodium hydroxide which is strong base and carbonic acid which is a weak acid. So the stronger component is the base, so the salt is also going to behave like a basic substance, right? You don't believe? So let's look at an experiment here which is a demonstration of this very same fact, right? So what we have here is a very famous experiment. You have seen this, I'm pretty sure. You take an egg and you put it in a beaker containing vinegar, let's say, or a glass containing vinegar, right? So as you can see here, you can see that the egg is slowly, some reaction or the other is happening inside, because you can see that bubbles are getting formed, right? So this is an experiment where you might have heard that they are creating what you call as a transparent egg, a egg that is bouncy, right? So what exactly is happening here is, you have calcium carbonate. You know that the eggshell consists of calcium carbonate. This is also a salt, right? So this shouldn't react with any acid, right? So we are speaking about a salt. But no, here as far as this calcium carbonate is concerned, this is a salt that you can think of being made of calcium hydroxide, a strong base, and carbonic acid, a weak acid. So this salt is, even though it is a salt, it has this basic character, right? Because the strong component here was calcium hydroxide. Of course, how do you exactly determine its basic strength and all of these is a different story. We'll do that in class. But yeah, as far as this calcium carbonate is concerned, it is basic. So this is something that can always react with acid. And as far as the other thing that we have here, vinegar is also an acid, right? So vinegar is your acetic acid. It's a solution of acetic acid, roughly 20-25% acetic acid solution. So yeah, of course, there is a possibility of reaction between these two, which is exactly what is happening. You are getting calcium acetate as the product, which is soluble, and that is why it's remaining in solution, and carbon dioxide is produced in this, and that carbon dioxide is what is escaping, right, in the form of bubbles that you can see in this experiment, right? So what we end up getting is that we have this soft egg where all that, you know, whatever was brittle, that calcium carbonate has escaped because of the reaction between a basic salt and then acid. Not an acid and a base reaction, but yeah, somewhere down the line we'll study how you can think of your calcium carbonate, the as also as something that is basic from other point of view, as something that can accept an H plus, as CO3 2 minus, as a component that can accept H plus and convert into HCO3 minus or H2CO3, which is the eventual reaction that is happening here. I hope you had fun looking at this experiment.